Hello, what's going on? It's Jun-chan back on stream to do some Haskell. GPU, yes, we are finally running our code on the GPU after many months of struggling with just simply setting up our system and drivers to do so. But we're finally there, and so let's convince ourselves by actually running the example. For instance, right here in like 10,000 particles, and there we go. So this is using a naive one algorithm, which is O(n) square. So with 1,000, we're supposed to be trying to run at 60 frames per second, frame rate 60, but clearly we're not. It would be nice to have a counter here for FPS. So I've had that thought also earlier today because I was watching some earlier video I took which were showing the actual like low-level C compiled NBody program from the NVIDIA samples library, and that goes super fast, of course, whereas this is slow. It's slow probably for a few reasons. Slow because we use the naive algorithm, that's O(n) square. O(n) square. We can get to O(n) log n, I think is where bounds hat goes. I'm pretty sure that it's not written here, but we can actually find that out. But let's try with less particles at the same frame rate. So yeah, same frame rate here is fine. And things start slow, so let's see. If I start fast, what do we see? Well, we might want to increase the gravity or the... I don't think we can we? Let's see, what can we do? We can do -- help. And bodies times the disk size of particle disk, but I'm not sure. That's actually, I know, mass. There we go. Mass equals. So we'll put them at, let's say, 5 times the weight. That's not very nice. Let's say 10 times the weight. Maybe 100 times the weight. How about that? Yeah, that's more like what I wanted to see. Okay, so 4,000 particles, it's not ridiculous, right? It's still very smooth and dynamic. Seems like something's happening, right? So that's not too bad, but obviously when we start going in the 5,000 realm, we see there's a frame rate drop right there. I mean, it might be hard to see on Twitch, but I can definitely see frame rate drop. So it would be nice to have a frame rate. So let's take a few notes, and let's also go back to our usual housekeeping shenanigans. So start with copying this, and let's see. So we have ran the NBody example in the GPU. Implement the Barnhart's implementation. Okay, so there's a few things, especially here, that we can now add here. There we go. Implement the Barnhart approximation. But maybe before that, we want to add an Fps counter. So let's check this out. It should be in the gloss library. Also, we're using the gloss library, and that was something that we were checking out last time. If we go to 3D rendering, then we probably need to move out of that, right? Because this is vector graphics. Uses OpenGL, but for 2D. So we want to move to 3D. That's going to be a big thing. But let's see whether Gloss has a, let's even search for an FPS counter in Haskell. See what that would look like. FPS, yes, must include counter, rendering, time variable stays constant. Okay, let's see. FPS. Okay, so let's see whether Gloss without Haskell. See a frame per second in games, but does this have anything to do? Okay, heads up display. Yeah, I don't think this will have anything to do. Pressing spacebar should give help in various options. Okay, is that something that actually exists here that I don't know about? Spacebar, no, not at least on the Haskell thing. Haskell version 10 years ago. I wonder if that's been actually completed. Who knows? Probably not. But it's also, who knows? Okay. Yeah, Gloss is maybe way too bare bones. So what do we have? Let's see. What did Duna use as a like some of the examples? What do they use? Examples. Kira, that's used WX. Yeah, I want to use like the Duna distributed example. And that one, I think it uses what I want, which is SDL2. And Haskell SDL2 FPS counter, frame rate, example, frame rate count. How many frames have we drawn until now? Move everything by frame count for added chaos. Delay to keep frame rate constant. Okay, so I mean that gets the frame rate, but clearly doesn't do anything with it apart jiggle or something like that. Frame rate counter. What does it say in the C++ library there? Get ticks. Okay, so basically we're pretty low level, so we should do things manually, I believe. How strange. Wow, I think that's yeah, that must be the algorithm there. FPS, but I've essentially made a simple FPS counter for this tutorial. Okay. Draw renderer, new FPS. FPS. Yeah, many FPSs. It's your frame rate, right? How ticks and time work. Okay, so that's the framework, the frame rate that we could use. Draw renderer. Begin looping at 0. Update the world. Draw color, clear render. Draw rendered new FPS world. So I suppose that that's what's supposed to be. I uses Apex. 2018. I see. Apex is one of the ECSs in Haskell. The other one being Ecstasy that I've tried from Sandy McGuire. Okay, run system. Right, okay. Run system. Draw rendered new FPS. Draw must be part of. Oh, hi there, Counterin. I'm good, thank you. Good to see you. Yeah, pretty good, pretty good. I finally got. Check this out. Actually, that's going to make you happy as well. I got my the Haskell example to run with the CUDA library and everything set up on NixOS. Finally, after like 5 months, basically of going from Windows to NixOS to, you know, trying the drivers, the graphics card issues, and yeah, finally it actually runs, and now I can actually do some Haskell. So it's pretty cool. Yeah, thanks. It is on NixOS. It is absolutely, yes, NixOS. And so, yeah, basically, maybe I'll walk you quickly to the stuff that I had to do. I had to, so you know, I installed Flakes system-wide, and I had to override this Linux package 419 in order to get like an old version of the NVIDIA driver, so that I could work with the Haskell libraries that support like the 10.2 version of the CUDA driver. So that was something in itself, and then I had to import that same library also into the local flake for this for the accelerate examples, and actually import the driver by name inside the Nix develop environment, and you know, a bunch of other stuff, but now finally it does work. So I actually can play with like bigger masses. Maybe this goes a little bit too fast. Let me maybe put 3 here, see what goes on. Yeah, maybe it shouldn't be that messy, maybe. Yes, there we go. That's pretty. Ta-da. Didn't work too much with Flakes. Is it better? Well, it is supposed to be better because it is because actually the regular way to do derivations usually depends on the channel that's in the environment, whereas Flake pin the channels basically, or pin other flakes, which means that it's really reproducible. Whereas if you move a derivation from one Nix system to another and they use different channels, then you can actually have problems reproducing the build. So yeah, so it's an improvement. And then also the whole Nix develop stuff is right, exactly. Yeah, there's several ways to pin. There's also Niv, right? But Nix Flakes is the thing that is adopted and is moving from experimental to released in the next 2010 release, 20.10. It's coming out very soon, or maybe actually already came out. I don't know. Yeah. So and Flakes for developing in Haskell, I found that was actually a sweet spot for me. That's what it looks like. Yeah, I'm able, you're able to specify to pin indeed Nix packages, but inside your definition, you can define, like I use call cabal to Nix to convert my cabal file into a Nix derivation on the fly. And then there's this dev shell that provides this Nix develop here, and that's much faster than Nix shell. You see, I'm already in there. There's nothing to recompute. It's more immutable than the old school Nix shell, and yeah, it's that's nice. To do the REPL, it's a little bit more tricky. Want to test it? Not sure how much it would give me over just import a pin or just fetch from GitHub. Yeah, I mean, I wanted to sort of see where things were going, and I don't know if you're aware, but also the whole Nix command is also changing. Instead of all the Nix blah from before, it's now Nix space and a whole bunch of thing, and Flake is one of the top level commands there. It's with the management of the registry, and it's been developed by the folks at Twig that are key Haskell and GHC contributors. So definitely recommend you check that out. If you do Haskell, then I mean, at least for me, it was fairly it made sense to switch. Let me put the thing in the chat. There we go. So yeah, so I'm pretty happy. I've been, obviously learning kind of the hard way and with a pretty complex setup. Like also, yeah, I didn't mention it, but yeah, I mean, no, I did mention it. Like I have to use old version and so on, and so that's fun. And now what am I doing? Well, I'm actually, yeah, I have a few things that I'm looking at. The immediate one that I wanted to add an FPS counter. Switch object, yes, of course. Have I worked with DAL? Yes, a little bit. We use it a little bit at work. It just seems that yeah, as soon as your DAL files become pretty big with a lot of dependency, it takes forever to compile. So I'm not I'm a fan of configuration typed configuration and non-Turing complete language. That's awesome, but in practice with more modular DAL programs, it seems like yeah, you spend quite a lot of time in compilation. It's not a huge problem, but like everything that lengthen your feedback loop when you're trying to change things and you have to wait each time, that kind of like it's not good for flow. Trying to use rewrite with schemas. Yes, that's to do like bidirectional stuff, right? Like going from for instance JSON, but having a DAL schema that allows you to actually rewrite it into a DAL expression and keep a bidirectional transform between legacy stuff and DAL stuff, right? I'm aware of it, but I haven't tried it so much. Yeah, that's definitely one of the things I was interested into in order to avoid or to allow 2 entry points into doing modifications. But yeah, I think it takes quite a lot of work, like any... oh, you can't find examples. Yeah, I haven't dug into this. Yeah, I think I've seen probably the same thing you saw. I think there might be just... I think I've seen one maybe article on it, and that was pretty much it. Or maybe even it was like some piece of code inside a GitHub issue or something. Yeah, it felt like it was pretty bleeding edge. Okay, so is this? So do I switch to SDL right away, which is kind of 3D rendering? Maybe I just don't add an FPS counter yet, and I just instead I do some Haskell and I implement the Barnhertz approximation. I think it makes sense to do that. I think I want things to run fast, and then I'll make them pretty. So let's do that. Let's go back into my Barnhertz code. Okay, so here it is. So let's look at the naive thing again. Right, so we're in accelerate, and here we fold with plus, starting with 0, accel epsilon, accel, where is accel coming from? Okay, I'm gonna need to retrace this. Maybe I should listen to my own stream when I actually looked into it. So you zip with rows and columns are the replicate takes a shape which is like this kind of, it looks like a type level. I think this is like a witness. This is a proxy that gives shapes, and this I think is all columns, and rows is all. So z is 0 and n is the dimension, and so first dimension, or maybe third dimension, second dimension, first dimension, something like that. And so right, so it replicates n time in the directions of columns, and so all the bodies is a vector, right? Bodies is it's inside the act monad, and it's a vector point mass. N is the size of that vector, and so we expand that vector across this matrix, and then across another matrix. I mean, it's not a matrix, across an horizontal vector and a vertical vector. Right. No. We take all of the bodies in the vector, and then we replicate it all across the matrix, and then we do the same thing, but we lay it out instead of like, so calls is we lay it out in the column and we replicate it n times, and then rows is we lay it out as a row and we replicate n time, and then we zip this thing together, which is equivalent to so zip with Haskell epsilon. So Haskell is probably going to take epsilon, a row, and a column. I don't have HLS installed here, so that might be something we want to do at some point, maybe soon, because it's going to be a problem to not have it. Let's see, maybe I just need to activate it actually. Configure Haskell, not like this. Settings, open settings, Haskell, and what's up? hls.log formatter. There we go. That's a thing. Sync is ignored, and that's a next door for HLS09. Yeah, maybe, but probably not actually, because I'm thinking, let's see, Haskell bad dependency. Okay, what's happening there? Yeah, we use GHC 810 here. And which HLS version? Yeah, 09. Okay, so you are using that guy, okay. But is that the one that's in my next develop though? Haskell language server. It is not. We use 1.0.0, so that's why it would not work. Do you install and define UVS configs in Nix? I do not. I do not. Do you do that? I've had to. Yeah, basically, I haven't updated it since I installed it. Is there some good reference? Like, what's the next best thing I could do? Because also I haven't updated it in like forever. It might be that the fact that I use flakes actually turns out to make it so that you can't teach me how to do the next thing. Because here, what am I doing? Must be in my home. Yeah. In my home, I have. Do I have VS Code here? No. Uh-oh, I think that must be one of the things that I left in configuration.nix. Let's see, programs, VS Code. Yes. Yeah, right there. System packages. I merged to the Nix packages some tool that might help with it. Ooh, VS Code env. Let me go check it out. Excellent. VS Code env. It's GitHub. There you go. Nix wrapper over VS Code that can set a VS Code with workspace configuration from Nix. Very cool. So I suppose that's the top level, and well, no README. Shall we write a README? No, it's all good. It's all good. I know how it is. Sometimes you just want to move fast. But yeah, let me pin it as part of something I'll look into when I want to actually get. Well, I'm actually looking at HLS right now, but I could use I could take a look at VS Code env. There we go. Right, so I'm gonna have this issue here, which is that I need to use this HLS. So this is very manual, but at this point I'm just gonna do that and then reload, see if you can replace the described code. Excellent. Yes, that sounds great. Thank you. And yeah, let's see. So if I go now to yeah, the fact that I'm inside an example with the Cabal project, yeah, I don't know if that's going to work. Naive. There we go. Yeah, we need a cradle as well, but that's probably fine. Yeah, it seems to be compiling things. And I know it fails to build could attend to why. Missing CLGL. OpenGL row. Okay. Could it be that it's probably the problem is that it's not using the Cabal.project, which is if I remember, yeah, that's an HLS bug. Something that people were bouncing to across the fence to each other. GitHub, but maybe that's something I can set up in hie.yaml file. Possibly. Simple example. Yay. I see. So that's a per project extension configuration in Nix. Am I right? I could start without Nix extensions. Okay. Yes, exactly. Okay. Yeah, that's cool. That's very cool. Right, with an extensions.nix file. Okay. Let's go take a look at it. That has nothing in it. Okay. You're actually sourcing your you published your extension. You published extensions as a Nix package thing. That's pretty cool. Do you know about this problem? The fact that right now I'm using a kebab project to compile a package that's, you know, out of tree here. And I think I need an HIE file in HLS in order to say that I have something elsewhere, because HLS doesn't read the kebab.project file, I think. Oh, that stuff is so complicated. Cabal, component name, path. Yeah, no, that's not gonna work, I don't think. I actually don't think I can even do what I'm trying to do. Unless it's possible. No, I don't think it's possible. Yeah, I think I need to switch to stack, which I absolutely want to avoid. So this sucks. Multi. I guess I could maybe put if I put the library inside. No, I don't know. It's probably not going to work. In the project, you will load it and wait. And then you can install VS Code extension from within VS Code, and when executing it, it will automatically fill the file immutable extensions with definition of each extension. Oh, that's pretty cool. Huh. Right, removing the global things means that when you update, you don't lose all of your extensions, right? Which is why I haven't updated. Yeah, that's very cool. You know what? I'm going to copy what you said and write it as a note right here for when I'll tackle this. And I'll also put the link to your example, because I think that's what we want. Okay, cool. Yeah, so another build environment difficulty here. So HLS, another thing you could do is specify config JSON and keep in JSON from right. So yeah, I see what you're saying there. Yeah, that makes sense. Obviously, that's separate from installing the extensions, but it would mean that you'd have the config also available. It makes sense. Okay, so Haskell language server. Local package override. Cabal. Project reference. Yeah, I think the problem is just that it doesn't deal with Cabal.project. If I remember correctly, there's an issue about this. What's this? In the Cabal.project. Hold on. Let's look at the log again. So we have HLS version 1.0 GHC 8.10. Start the LSP server. Tries to find a cradle, doesn't find one. Tries to build things. But fails right away. And I suppose that's because... So okay, there must be a Nix way to do that. There must be a way that I can override the Haskell package with my local package as a Nix dependency. Actually, I think that's in the NixOS discourse. Discourse and Nix Haskell development. Yeah, that one. I think there's override for a for remote override. Is there going to be an override for local override? Dot name of project cabal. That is go cabal to Nix blah. We can import other overlays like Omolu. This is where we create the duration for your project. Yes, that's for a project, but so could I just maybe? Oh, well, actually, I can't leave the Git repo. So I suppose I would have to put the file in here. I don't think I can do dot here. I mean, you can try. Not that. Let's call this CUDA and then say my Haskell packages CUDA and dot CUDA 10 to CUDA dash 0.10.2.0 and CUDA.cabal. I don't think that's going to work, but we can try. And then I suppose when doing that, if I add CUDA as a build input, that would actually maybe work. Was it ready and waiting for me? I don't know. We shall see. That seemed a little bit ambitious. Forbidden restricted mode. Right, Nix store. Okay, yeah, no, I don't want you to go in Nix store. I want you to go. Okay, fine. We can pin this thing to the actual path and not the relative path. Let's try. Forbidden restricted mode. Well, at least it's the right path, right? Let's double check. Yeah. Okay, well, maybe we deactivate restricted mode. Okay. Nix disable restricted mode. No, we don't care about the browser. Okay, Nix. Restricted mode removes restricted eval. How to get around restricted mode using Nixflex? Yeah, because Nix is reading blah and on the string. He tries to put it into the store. Yeah. I mean, yeah, there's a more Nixy way to do this, I'm sure. Which would be something like I built the CUDA 0.10.2 locally in my store and somehow I import it here as maybe an overlay or something. Maybe I can even just put the path, or maybe I can make it a flake actually. Actually, it is a flake. Hold on. What? It is a flake. Does this mean I can just import it? Maybe actually. Hold on. How would that work? How do I import a local flake? Nix import local flake. System wide manager. Inputs. There we go. Path. Directory example. For absolute path, you can omit path. Okay, well, hold on. So what are we doing? We're doing inputs dot CUDA dot, let's call it CUDA10.2, right? CUDA10.2 equals path and the path, except like that. And CUDA 0 10 to 0. Do I need to put the flake.nix? Probably not. Probably find it itself. Okay, so now what? Now I also import CUDA in outputs. And then, well, that in is part of what gets into the output, yes. So then I'm in the wrong thing. That's where I want to be, and let's put it here, and let's call it CUDA10.2. It's a little bit ugly, but at least I recognize it. And then what? Then we don't need that thing, and then here we just say CUDA10.2. I don't know, maybe worth a try. And okay, must be a semicolon here. Set but get a string. What's that? At flake 8. Okay, so maybe right, dot something. Dot URL. Cannot find flake CUDA in the flake registries. Yeah, I don't want you to find it in the registries. I just want you to find it in the path. What's the problem with that? Do I need to add the local thing? Have you found even? No, I think you're trying to find flake.cuda, but okay, let's make sure I haven't left something strange. Doesn't seem like I have. This has that CUDA10.2 right here. So why would you want? Do I need to actually call it? No, directory example. That doesn't make sense. Let's call it CUDA local. How about that? And then CUDA local, and then CUDA local. How's that? Cannot find flake. Oh, no worries. Counter run. It's all good. It is all good. I am trying to use flakes for the first time, to be honest. That's really what I'm trying to do. But I'm not really succeeding here. Packages. Okay, let's look closer. .url path to repo. It is a git rep. Oh, have I made it a git repo? If I haven't made it a git repo, then it won't work. Git status. Yeah, it's not a git repo. Okay, git init. and next develop. And maybe I need to add stuff. Yeah, I'll add stuff, but I won't add stack work. So restore staged stack work. Describe the better VS Code functionality. Aha. Let's check it out. When the executable exits, it updates the immutable extension file, which is imported when evaluated by Nix later. Okay, I'll put this in my list of things in there for when I look at it. Okay. Right, so I probably need, so I have added the things. Oh, you can't resolve. Okay, well, just git, yeah, hold on 1 second. Just rm-cached. Okay, let's do that. Instead, git rm-cached this new style and stack work, please. Okay. And that looks fine. And let's see whether now it's no. Cannot find flake.code in the flake registry. So, okay, let's see what that error message is supposed to be. And of course, flake blah. And that would be directory. Pain point with flakes. Yeah, I suppose maybe local registry, not found in here, but where the local entries are per user or system wide. So do I need to actually add the flake itself to the registry? That kind of makes sense actually. Nix registry. Add replace flake in user flake registry. Add. And from URL to URL. So path. And let's take the thing. Do I add a path to I don't know. Okay, let's look at an example. Next registry add example. As subnex. Add next blah and next looking for next. So I just do CUDA and the blah. And let's list available next flakes. Flake CUDA user. Sounds reasonable. Circular import. Okay, did I not save this? I thought I did, but here, that's not good. Boom. Is that? Oh, maybe we shouldn't call it CUDA. I don't know. Let's see whether what's going on. Okay, I can't type anymore. What's going on? Okay. Ah. Well, that's nice. Is that going to work? That'd be pretty amazing. But I don't think it will work because I think I need to hook it. Oh, maybe it will. Hold on, I actually forgot what I was doing now. I added it here, which is me. Oh yeah, HLS. That's what I was doing. So in theory now, yeah, I don't think that's going to work. I think I probably need to instead override it here. I need to do something like overrides CUDA equal blah, and then maybe it will work. Okay, let's try that. CUDA equals CUDA local. I think that makes more sense, but we shall see. Okay, why not? And then let's reload. Okay, no, let's not do that. Okay, let's not do that either. And reload. And see what HLS tells us. And I need to go into a Haskell file, like, let's not go into an example for a start, just to make things just a tiny bit simpler. Let's go to lib. Gradle found. CUDA tend to libCUDA. What's going to happen there? Failed to build CUDA, yeah. Can't find NVCC. That's a different error. How do we know it's the right CUDA? It's hard to tell. So we solved all of these dependency issues for building, but now we have the problem for that's because I do kebab build in here. Something I haven't tried is to actually just build the flake. That doesn't work. Wow, LD Gold or UHC. Oof. No PKG config found. Right, so definitely our flake is super flaky. We can nix develop, but clearly we can't nix build. So, well, what about if I run Haskell language server from here? Oh, what's that gonna do? What do we need to be running it with? Trying to regenerate the index. Could be that it works from here because here we have the right environment, maybe. Well, yeah, look at that, it's linking it. No, but that's the setup. But it says it found the CUDA toolkit. Yeah, I have the feeling that this will work. Well, it's a bit ambitious. At least it's moving forward. I'm unclear about which version this is actually building. Is this Is this the local one or not? It's hard to tell because they have the same name. It won't be called CUDA local here. But we can trust probably that this has worked, in which case it is actually pulling in the flake. It's pulling in the flake, but I don't even know if I can nix build that flake, to be honest, because it's probable that I haven't yet had to nix build, I just had to nix develop, so maybe the nix build of this will also fail. Also, nix building a Haskell package. I mean, I think I picked up that from a Haskell example, but it's also possible that it's not gonna work. But let's see. It seems to be moving forward on a lot of stuff. The problem being that yes, I know what I could do here then. I could use the Nix shell extension, and so that HLS is run from within the shell, and then it would, if this succeeds, then instead of calling HLS from within the global, from within the Nix store in the global environment, it will call it from inside the Nix shell, which is what we want, because our Nix shell should be good, although this is not a good sign. This, I think, we fixed in the local flake by how do we fix that? Oh yeah, we fixed it by by importing the .lib and the NVIDIA X11 Vulkan Beta. So maybe I need to import those also here. Okay, what's that? Okay, that's HLS. Yeah, this error popping again. Seems to be rebuilding a lot of the stuff there. It's just finishing. Yeah, it's building all of the examples. And it has some red. But I think that's just the cradle, like the default cradle that's being built. And there's tons of examples, and then what? Are you on the loop? No. No, you're processing all the files. That's what you're doing. Completed. Okay, so let's see. We should be able to reactivate the Nix shell extension. Nix shell. Nix environment selector, that guy. Yes, so Nix select environment and select the shell.nix, right? And it's applying it. And then it's going to ask me to reload, I think. Yes, reload. And then I probably need to deactivate or change the path to my Haskell language server. So we can do this with extensions and Haskell and extension settings, and we can remove that and say find it yourself now. And so now in theory we're picking that guy up now with the Nix developer environment. So let's double check whether that works or not. Boom. Haskell. Server crash 5 times. Cradle type stack. No. Okay. just delete the. Yeah, you know what? Just be gone. Stack. We're not using you. Be gone. And then let's reload. And let's go back to internal LHS. Oh, yeah. We need to also, do we need to reswitch? No, we're in the shell.nix. Let's double check that our shell.nix is, oh, yeah, it is flake compat, so I think that's fine. Okay, and then we go to internal, and we wait for Haskell to show up. It's right here. And what does it say? Message parse error, cradle not found. So is that fine? Is that not fine? Oh, holy moly, it's working. Okay, I'm still super surprised when anything works with this setting. It is pretty hard. Solver, naive one, Haskell, tell me. Oh yes, types. Oh, that feels good. I did a thing. Amazing. I'll take a tiny break and I'll be back. All right. I am back, and yeah, we totally did a thing. We have types HLS working with our crazy Nick setup, so that's pretty awesome. Also, I think I succeeded in or maybe not. Actually, I'm just wondering whether this will work without the flake that we added. So let's try it, because we don't want to add craft if it's not useful, right? Create a local. Cannot find flake with a local. Ah, yes. Right there. Can I? There is a way to do this, I think. Is this? I do not know, but I think maybe just like this. How about that? Yeah. Okay, I remove killer local from the log file. And then we reload. And we go to our bounce hut, or maybe naive, and then we go check out what Haskell says. And Haskell says hello. Haskell is happy. So I think it doesn't need well, clearly it didn't need that flake reference. Why? Well, because here we use the cabal.project, I suppose. Yeah, I suppose we use. We know we're using cabal. Yeah, I'm not sure why that works. Maybe because it's already built. Meh. We won't learn exactly how it is today, but I want to use those last 15 minutes actually writing some Haskell, so let's pass. So Haskell is what is in common body, so let's go check it out. And right, so that actually calculates based on a smoothing parameter epsilon that we pass, which is the I think right, is if epsilon, if the distance is less than epsilon, then we consider 2 points to be equal, or to be like in the same quadrant, I think. Is that right? Let's pull back our the blog post that we use for the Barnhertz approximation. So let me see. I think that requires me to go back here, and then inside this folder, look for Barnes Hut, and just Barnes will do. And yeah, unfortunately, yeah. Right. So okay. So let's totally reuse that. Actually, I think does this mean I have it here? No, I don't have it here. Okay. So let's go there. But I have it here. Okay. So implement in accelerate NBody. So that's code from data parallel Haskell. So old code, but it will be useful to have. And then the octree construction with the feature sequence nested data parallel. Okay, so this is like super advanced idea of using some of the very latest features of accelerate, thinking that maybe they will be accelerated by the nested data parallelism that's there, but that's very speculative. So actually I don't really have what I want. Reddit post. Yeah, I didn't even take a note of the blog post that we looked at. That's sad. Let's see if we can find it here. Search tabs. Barnes Hut. No. Okay, and how about in my history? Barnes Hut algorithm. Well, looks like we're going to have to find it somewhere. So that's one. Yeah, why not? That's not bad, right? It's not in 3D, but it's all good. Measure forces, but this doesn't seem as detailed as I want. So let's look at many body problems and bodybuilding. Yeah, I remember seeing that one. Two-dimensional quadtree. Theta, I think, is where we want. Okay, let L be the size and length of the cell currently being processed, C, and the cell currently being processed, C, and D the distance from C center of mass to P for any particle P. And if L divided by D is less than theta, then approximate the particles in C by the center of mass. Right, exactly. So so that I think is epsilon, isn't it? In our example. Yeah, what's called the smoothing parameter. That's the point being accelerated, the neighboring point. So I suppose the point that we are considering, that a neighboring point. I think that's the the other point. We're trying to calculate the acceleration contributed by J to point I under consideration. And we'll sum over all the J's different than I. And so if the J right, the Barnes-Hut algorithm is going to be such that if the J is I mean all the J's that are at sufficient distance. Do we even use the epsilon in this? We do use the epsilon, but maybe it's a different epsilon, because for that naive thing, yeah, probably it's a different epsilon. We're going to need another, probably we're going to need a theta. S to the power of R. So force of AJ is gravitational constant, the product of the masses divided by the square distance, with the product of a normalized distance. So that's F, and so total force is the sum, and Haskell is just one of the things, right? Haskell is just it's just this guy, right? The integral from I is the sum of Fij. That's done by the naive guy, I think, when we zip with and fold with plus. Then we do the integral. but then there's an epsilon here. As the bodies approach each other, the force between them grows without bound, which is undesirable. Okay. Okay. No, so that's just to try and minimize like the singularity at 0 for when I approaches j, which is otherwise going to lead to to weird infinity effects when particles get close to each other. Okay, so that's very specific to that naive. Well, it's kind of specific to that naive evaluation. Maybe it depends. I forget how acceleration is actually. It could be that actually we still use acceleration, but that the mj that we pass to it is a kind of an aggregated mj, depending that's based on that octree calculation. So maybe we keep that and we still have a smoothing effect, but we need another parameter that's going to be a theta, which is probably going to be a expr, to be honest. And it's just going to be theta. So calc excels with where does it take an int? Because these guys take an int, which is ignored. Oh, was that me adding it? I think maybe I added this. Oh yeah, I did, but what? I replaced the expr by an int? Why did I do that? Where do we call things? I think simulate advance. Well, time world NBody main, advance world. That's right. Advanced bodies with the solver side and a constant. Right, solver. Right, we pass size. Okay, and size is an int, and right. So we need size. Oh, it's the window size. Why do we need the window size? Okay, I need to just check accelerate examples again and see what we're doing here. Examples, NBody, and the main. And so solver didn't used to take size, but now I'm passing size. So I think that must be me starting to think in terms of adding the size of the window in order to have something to calculate the quadrants. Okay, that's fine. So I used refactored such that. So this is strange though. I don't know why I had an expr. I don't think there was one, right? That's the that's probably the kicker here. Naive. Yeah, that's right. So I must have, well, apparently I did a commit. Yeah, whatever. So int is size, and I ignore it. So, but we don't want to ignore it here. So, oh well, look at that. So we take it size epsilon, and then what I'm saying is probably we also need a theta now. And well, we put it here, and then bodies. That's fine. And yeah, let's say that it's not implemented yet. Let's just delete that. Hold on, let's just make sure. Yeah, vector accels, that's fine, except that this needs to be an int now. Okay. And then I started trying to create some kind of tree, which I suppose must be based on this guy, right? Probably. I don't remember. Build tree. Boxes, BHT, BHT, BH tree. Double blah. And so instead I think to have started to do my own tree and do like a build tree. Ah, there is a build tree. And yeah, you know what? I seem to have been maybe a little bit further away than this and this. And well, right, so let's say undefined, how about that? And then you can be assigned, why not? What would be a problem here? Yes, well, we don't have an empty constructor. Yeah, remember that I was wondering whether I needed an empty constructor or not, but I think clearly I do, right? So why don't I have it? Who knows? Let's add it, empty. And let's show this guy again. And then we need vectors. Okay, well, just fix that. Brackets. Except, I see we have two v3s. So which one do we want? We want the point mass. This is strange. R. Okay, so common type has okay, I think I need to import qualify here. That's going to help or not? Brackets. Yes, does help, except now these guys, I suppose maybe I can import them. Vector arc exp. And okay, and then what's that? Oh yeah, there's definitely lots of, I know, hold on, branch 1, 2, and then the 8 things. Should have 10 arguments, there's been given 12. Okay, very well. That must work then. And then what? Then we don't have size. We cannot. Cross slice. Yeah, that's scary. We're trying to do some kind of fold. And then what's up with that? V3A2 with a point mass. Right. Yes. What's a point mass already? Type maybe. Yeah. Position. Yeah. Okay. Yes. So, and mass is an R. Okay. So let's try that. Yes, that was, so that would mean that I would need indeed another parenthesis. Maybe not actually. And then R would be what, 0? Yeah, something like that. And then Excel's not here. Well, we could, I think, get it from it's from common body, I think. Yeah. So there we have, and then constant z, a dot constant. Okay, so that is from here, and z as well. Z, the true or not? I think maybe z is a constructor, isn't it? No, it seems like that works. Okay. And then what? Then maybe it's time to try and understand what I've written here. Okay, so what are we trying to do here? we a.map this calculation, which is calc, to the tree. But the tree doesn't have the right type yet. But okay, so, and the calculation expects a body. So yeah, indeed, that's not going to work. An EXP point mass. Map takes something that goes from an XA to an XB, an ACK of array SHA, and returns an ACK of array SHB. And we want to return a ACK of vector accels. So calc is of type what? Thank you. Yeah, that's pretty much what we would like. Can't you give me that? Okay. Can you please copy that? And then there you go. So that makes sense, I suppose, if we take a point mass. Okay. So, but then we obviously can't map over the tree, because the tree won't have the right shape, right? I mean, we can, with map, we can change shapes. I know we can't change shape. SH is the same. So clearly that won't work. We need to do something to our tree that's going to, is that right? I need to have an expression of the algorithm that makes sense. Gorgeous. Yeah, I want gorgeous. I think. Yeah, that's nice. Speeding up the brute force NBody algorithm. Group nearby body, approximate them as a single body. If the group is sufficiently far away, we can approximate gravitational effect by using center of mass. I like this description. Indeed, that's in a nutshell exactly what the algorithm does. So that's a good start. Center of mass of a group of bodies, the average position of the body in that group, weighted by mass. Formally, if two bodies have position x1, x1, y1, x2, y2, and mass is m1, m2, then the total mass and center of mass xy, given that blah. Parts are using a clever scheme for grouping together bodies that are sufficiently nearby, because it recursively divides a set of bodies into groups by storing them in a quad tree. A quad tree is similar to a binary tree, except that each node has 4 children, some of which may be empty. Each node represents a region of the 2-dimensional space. The topmost node represents the whole space, and its 4 children represent the 4 quadrants of the space. As shown in the diagram, the space is recursively subdivided into quadrants until each subdivision contains 0 or 1 body. Some regions do not have body in all their quadrants, hence some internal nodes have less than 4 non-empty children. Hold on. Each subdivision contains 0 or 1 body. Yes, right. So the leaf contains 1 and the empty contains none. Okay, so let's note here that we're using this and where we use the terminology or whatever. Yeah, so this is subdivision containing 1 body, and this is a subdivision containing 0 bodies, and a branch is an octant. Yes. And then you're right, the internal nodes have less. So what is it already? External and internal, how does this work? External node represents a single body. Okay, so that guy is an external node. External node. Subdivision containing zero body. This guy doesn't have a name, and that's an internal node, and that's an octant, right? Right, an internal node represents the group of body beneath it and stores the center of mass and the total mass of all of its children body. Here's an example with 8 bodies. Okay, so you know what? We probably want to build that guy lazily. Can we build tree lazily? Calculate net force on a particular body. Traverse the nodes of the tree, starting from the root. Okay. Right. So the other option is that I have that somehow my tree has the equivalent of the foldable instance for the accelerate library. Let's see, accelerate foldable or traversable, maybe actually. Maybe we need foldable. But let's see, traversable, Haskell, data complex, okay. Traverse the real part first. Okay, let's see. I might have to do my own instances. There's a traversable instance for quaternions, but the question is there an foldable instance for ACK, or do we even need that? I don't know. Map is from accelerate language. Interpreter. Are we in an older? Maybe we're in a newer. There's no language here that I can see. Language. No. Okay, what's going on here? Let's accelerate language. Documentation source. Accelerate 1.3. Okay, I see. So it's actually data accelerates, and for some reason it's called language. Data accelerate. And yeah, the accelerate array language. Map. Mapping. Boom. There we go. Yeah, so how about traversing? Okay, what's that? Traversable of int. Okay. That might be interesting. I remember we looked at iTraverse last time. Was it in this context? It might have been in this context. I mean, clearly we want bodies here again. Yeah, that types checks. And then what? Then calc will build the tree lazily somehow? Let's look at the algorithm again. Traverse the nodes of the tree starting from the root. Yeah, so whatever tree representation we come up with, ideally we'll have a foldable or traversable instance for tree that will actually follow this. But then we might need to then map, what am I trying to say? Then I don't think we can express a.map into a traversable instance. So maybe we'll have to define instead a shape. Not sure. Element-wise operations. This needs to be applied to an array. If we can we lazily build the array? That's one question. In which case this could be sort of like tree bodies or something. And right, so what I'm doing here, build tree, I'm trying to start with some empty leaf at the root, probably. exp with actual type. Okay, sfoldl. Okay, give me the type of that. Okay, I see. Yeah, clearly I'm gonna have a problem here because sfoldl only takes 2 parameters, the expa and the expb, return expa. So I'm going to need to tuple width and point mass, I believe. And that would be a thing, but then I need the XPA, that's fine. The XPA safe, that's also fine, but then my ACK will need to be an array of the shape with the int. How that work? That's going to need to be a.map as well, I'm pretty sure. Right. Yes, I was trying to lens into the bodies here, I think. But I want bodies is a vector point mass. Then no, it's a body, and then I get the point mass of the body, and then the point mass. So now in theory I have an array of masses, but I'd like the position as well. Right, so I need to somehow do a lens that's going to also tuple. How about I actually do go or tweak and say that tweak will have type I'll probably add a vector point mass 2 arc of vector. What do I want? I want a width point mass. Width point mass. Is that right? If I say undefined, will you be happy here? No, because it's probably exp and not arc. Is that right? Better. Except bodies. We want to map. We want to match position mass. That's what point mass is, isn't it? And you're expecting array ADM vector point mass. Okay, I think that you're expecting this now because of the fold L and this constraint there. That's probably the dim one, blah blah. Right, an A array A dim one vector point mass rather than an ACK vector point mass. Oof, this is making me feel a little bit dizzy. Maybe I need to convert bodies into a basically bodies. Okay, hold on. Map. Could it actually be a map? Because bodies is no, bodies is an arc vector point mass. Okay, so arc vector point mass. That kind of seems right. What's going on here? Why do you say it's not used? It's used here. Yeah, I need somehow to lift bodies, which is an ACK vector point mass, to an ACK array blah vector point mass. So how do I do that? I think that maybe that's in accelerate linear. Maybe v3, or maybe just vector. Yeah, just vector. And what? We have instances for things, additive, and the zero vector sums. Not really what I want, is it? I want to move between an array and a vector, don't I? And I get a arc vector point mass. Arc vector point mass. I can get the size of it. So it seems like I should be able to look. This takes an array dim1 point mass, and that's probably a vector point mass actually. Hold on, let's look at the definition of v1. Source, please. Is it really v1 or just vector? Array dim1. It must be just vector. Or is that defined in instances? v1 instances. Yeah, I don't remember how this dim1 is going to play out. Size. Okay, let's. Is there dim1 here somewhere? There is dim1 for stencils. Where is this? Scalar data types. Yeah, I think I need to more progressively get back into this library. Clearly, past June had thought about it or spent a little bit more time while we were doing the infra stuff into actually reading documentation, whereas I'm like going back into it thinking it will just come back to me, but it doesn't, because I suppose yeah, it's been, how long has it been? About 2 months, or like, yeah, no, about like a month and a half, I think, since we hadn't touched it. So it's a bit distant, but we have I think we have a bunch of stuff in place to continue. So we have the blog post, we have some code, and we'll just need to maybe take a more principled approach to thinking about how we're going to write the algorithm. I think probably some of that stuff I actually borrowed from the data parallel Haskell approach. Let's take a quick look, but I'm thinking, like, I'm looking at this like assign. I don't see that I have defined assign anywhere here, have I? No, but I started on it though, so that's interesting. So yeah, I must have had some idea of what I wanted to do here. Wouldn't it be great if I actually had written something? But I didn't. But I suppose it's about, yeah, this is building the tree, so it was really about that initial assignment of each bodies to a tree. And maybe that's how we should start, with kind of a naive version that just sort of just uses memory and time, like, to actually do the allocation, and then we iterate to make this simpler. That might be the better case, and this was definitely the tutorial or the blog post that we were looking at. So that's it for now, and yeah, more Haskell to come on Thursday, and then yeah, then I'm actually going off on a vacation, so I will at least not stream for about 10 days, so I'll probably be back early June, and yeah, I'll be streaming from Portugal for a bit, because I'll be remote working, and so yeah, I suppose I will. I haven't thought about what I'm going to do with my setup. I'll probably just stream from my laptop and not try to be too complex. But I'll probably, yeah, I'll need to. Oh, but yeah, what am I going to do for I probably need to pick a project that actually is easy to deploy on my laptop, and so the GPU is definitely not going to do it. All of the data structure stuff, probably not either. GStreamer, maybe. It would be nice to be able to continue with that, but otherwise the good candidate seems to be PureScript. So maybe I'll be doing PureScript mostly in June. And maybe GStreamer. It would be nice to have GStreamer actually work on a Mac, to be honest. So let me make a note of that, because it means that probably next stream I'll actually prepare for being away. I think that makes quite a bit of sense. So let's write it down. Prepare for remote streaming, which will mean PureScript project, and that'll probably mean actually just pushing a bunch of stuff to GitHub actually, and then the GStreamer project, with the aim to make it work on OS X or Mac OS, as it's supposed to be called these days. All right, that's it. Excellent. Thank you so much for watching. I've been Jun Chan, and it's been nice doing some more Haskell, even though it feels like we're just bouncing off the surface here, because it's like accelerate, whole library that we've only really dug into once about a couple of months ago. So we need to reorient ourselves with it. But really super happy to be doing Haskell again. And Calteran, thanks a lot for watching, and for all of the Nix tips. And again, thanks for making me migrate to NixOS back a couple of months ago. It was definitely worth it. I feel really lucky that I've been able to learn more about it. So take care, and yeah, see you on Thursday if you're around. And otherwise, I'll probably stream also on Saturday, so we have a couple more sessions to prepare. And yeah, enjoy the rest of your evening. Bye bye.